Hi, and welcome to this video about proving a trigonometric identity. And we have two fractions added up on the left-hand side. And we want to prove that the addition of those fractions gives us twice secant squared of theta, no matter what theta is. When we have a trig identity, we have an equation that involves an angle or angles that can be chosen as any number. And to establish an identity or prove an identity, we start with the more complex side of the equation, and we use algebra and trig identities to arrive at the right-hand side, or whichever side is simplest in the equation. The equation we have is an equation that looks more complicated on the left. So let's take expressions on the left-hand side of the equation. Start with that left-hand side of the equation, and we're going to show that when we add those fractions, we get twice secant squared of theta. Now, when we add fractions and we are working with numbers, quite often we get to use common denominators. If the common denominator of two numbers that are denominators of fractions can be found, then that common denominator goes to a common fraction here on the right-hand side as a denominator. But here in our example, 1 minus sine of theta and 1 plus sine of theta are very different. I mean, there's sine of theta in both expressions, but they are very different otherwise. So when there is no common denominator, or it's not clear how to find that common denominator, we can always multiply denominators. And that can be a common denominator. Here we are going to multiply 1 minus sine of theta by 1 plus sine of theta. And then what goes on top is the cross multiplication of terms added up. So we do a times d plus b times c on top. All that gets divided by bd. Or in our case, we have 1 times 1 plus sine of theta, and then plus, and then 1 times 1 minus sine of theta, or 1 minus sine of theta times 1, same thing. Mark this over. And now we have a common fraction coming from adding two fractions up. Okay. Now, one of the things we notice here is that our denominator is very special. We have something minus something else times something plus that something else. And that type of expression corresponds to the subtraction of squares. And we keep to the order we see in a minus b. So we see a squared minus b squared when we subtract squares. And here we have a is a number, a is 1. And b is sine. So we're multiplying 1 minus sine by 1 plus sine. And according to the equation right here, we get 1 squared minus sine of theta squared. As for the numerator, when we multiply something by 1, nothing changes. We have 1 plus sine of theta coming from multiplying 1 by 1 plus sine of theta, same with this part, 1 minus sine of theta times 1. And here we have those expressions. And on the next line, we can say that on top there is 1 plus sine of theta plus 1 minus sine of theta. sine of theta minus sine of theta gives us 0, and 1 plus 1 gives us 2, divided by 1 minus sine squared of theta by notation. By notation, when we write something like sine of theta, all that squared, we mean sine squared of theta, or the other way around. When we write sine squared of theta, we mean find sine of theta and then square it. And then what we have here is 2 over, and 1 minus sine squared is cosine squared, because of one Pythagorean identity that tells us that cosine squared plus sine squared equals 1. So we can solve for cosine squared in terms of sine squared. To get cosine squared is 1 minus sine squared of theta. And then at this point, we double check how far we are from getting to what we need. We need to get to twice secant squared of theta. And so far we have 2 over cosine squared of theta. The two we need to get is already there, because this is 2 times 1 over cosine squared of theta. We can always separate the numerator from the fraction by putting the numerator aside and then writing a fraction as 1 over the denominator. And something else that happens at this point is that we see, okay, 2 times 1 over cosine squared, that looks really close to 2 secant squared of theta, because cosine and secant are related. Secant is the reciprocal of cosine. Let's try to write this expression in terms of cosine more clearly. Here we have 2 times 1 over cosine of theta squared, because when we have 1 over quantity squared, that's the same as 1 squared over quantity squared. That's 1 over quantity, all that squared. And then because 1 over cosine is exactly what secant is, we're thinking of taking the secant of theta and then squaring it. So here we have used secant of theta is the reciprocal of cosine of theta. Whoops, okay. And then 2 times secant of theta squared is 2. And then secant of theta squared is secant squared of theta by notation. Secant of theta, all that squared is usually written as secant squared and then theta. Notice that we write square on the function, not on theta, so theta doesn't get affected. And that's the solution to this problem. We went from the left-hand side, the more complex side of the equation, to the least complex side of the equation. So the most complex to the least complex. That's how we usually go, through algebra and through trig identities. Okay. I'll be uploading more videos about trigonometry. There are more you can find. If you have questions, let me know. I'll be happy to help you. And that's all. Bye-bye.